Hello friends. In today's class, we are going to discuss about three address code of an array. While writing the three address code for an array, we need to represent every kind of array 2D, 3D in a single dimension, and that we'll learn in this class. Hi everyone, and the next topic here is flattening the array. Okay, so this is virtually used in most of these three address code, and array is a particular concern because how to represent because we in three address code we have seen the assignment like a of I is equal to, suppose x is there, right? B is equal to, suppose a of I is there. But we haven't received any assignment here of 2 dimension and 3 dimension. Okay, so flattening the array or flatten the array is nothing but representing. This is the definition wise that we want to represent. We want to represent a higher dimension array. Higher dimension array in one dimension. Okay. 1D array, one dimension array. So that idea is we are calling it as flattening the array, and something about arrays, they are stored consecutively in memory, and in language like C and Java, the elements 0, 1 and n-1 are the index. Okay, these are the nothing but index of elements. Okay, so in other languages also there is a lower bound, low plus 1 and up to high. So array A is represented as there is a lower bound, so there is a low, and then there is also a high. So low to high, and that is something that is called as your generalized array, we can say a general array. Okay, general array. Okay, so now what we'll do here is in this section we will see that how we can represent a higher dimension array in a one dimension array, and I'll take some base value here, and this is the base value I'm taking. Suppose my low is equal to 1, and another parameter I need is the size of element. Okay, I need this size of element, and suppose I'm taking it as a 4 byte. So now suppose let's start with this 2 dimension, that suppose there is a 10. This is the representation that there are 10 rows and 10 columns. Okay, and in this 10 rows and 10 columns I want to represent in a single dimension array. Okay, so now if it is the case, then here suppose for smaller example there is a 1, 2, smaller instance, let's say 3, 4, 5, 6, 7, 8 and 9. Okay, so this is the elements of 2 dimensions. Suppose I take a 3, 3, and then I'll come to a 10, 10, 10, and I want this particular address. Okay, so here if I assign the address, this address will be what? This will be, let's say, suppose 1000 and 1004, 1008, 12, 1016 and 1020. So I want the fifth address, and that address is 1016. Now index wise, if I say that my index starts, the lower bound I say 1. So this is the row 1, row 2, row 3. So there will be row values. There will be row number 1, 2, 3. And column value will be also 1, 2, 3. So I want here A11 actually. I want the address of first row and first column. Oh, sorry. This is row 1, this is row 2, this is row 3. So I need the address of here. I need the address of A22. Okay. Second row, second column. To understand this, before reaching to the second row, okay, now we are on to second row and second column. So I write few statement here, one statement, and I'll say that before reaching second row, okay, first row is completed. True, right? So this is a true statement that I am here, I'm in this row, so this row has been completed. Now each row is consist of how many elements? Each row consists of how many elements? 3 elements, right? And this will come from where? This will come from how you have declared this. There is a row and there is a column. So each row is consist of 3 elements, and there it is coming from. Okay, so there it is coming from, that each row is consist of 3 elements, and that is nothing but number of columns. Okay. Now, second argument is before reaching to this, before reaching second column, one column is completed, right? So I have already completed this column, this column I have already completed. So means I have completed this part, complete part, and here I have completed this part, means this number 4 I have already completed. So that means number of element completed is here I can say number of element completed. Element completed is how much? Number of element completed will be equal to, in this case, will be 1. So, and if I just summarize this, that total number of element completed, total number of element completed is what? So this, there is a 3 element and there is a 1 element, and that is equal to your 4. So there is a 4 element has been completed. So total number of element completed here in this case is 4, and each next argument can be each element, okay, each element size is 4 byte, size is 4 byte. So now I can say that total 4 into 4, that is your total 16 bytes of the space has been taken. And if you talk about the address, then I'll just add here the base address value. The final address will be 1000 and plus 4 into 4, and that will be 1016, and that is the 1016 address of 5. Okay, so that way values are being computed regardless of your this, what is the lower bound, and size is something that is intrinsic, or it is about the architecture, what size does it support. Now with this I can write the formula here that the address, the final address of A of I is equal to, okay, so A of I, and I must know the context, then I'll do the generalization. So A of ij, for which address I'm talking about here is A33, I have already explained you. So let me talk about A1010 over here, okay, A1010 I'm talking about. So what I can say here is that there will be a base address, so base address plus, okay, now I'll do some computation for this ij, I minus. So here I minus, what I have done is 2 second row and only 1 column is completed, okay. So I minus 1, and then I'll put a multiplication over here, multiplication with what? And then the next argument is number of element. Each row consists of 3 elements. So the number of element in each row plus j is the column value minus, again the lower bound is 1. Okay, so here 2 second column, and we have already 1 column is already completed, so 1 less column, and into size. This is this formula is for what? This formula is for when the lower bound is 1. Now, had the lower bound has been 0, in that case, this formula will be different. And I can rewrite as base address. Okay, let me just put it a bit up. Okay, base address plus, here in this case, it will be much more simpler. I minus 0, it will be there. Okay, so if you're in the first row, okay, now just look at here, that if you are talking about this array and if you are like here, this lower bound is 0, then this particular value will be what? A11. Okay, so if you're on the first row, then you have already completed one row, so nothing to subtract. If you're in the first column, then you have already completed one column, so nothing to subtract in that case. So that way we are not doing any subtraction over here, I minus 0, and then I'll write here plus j, and then I'll put here a size. This j minus 0 also, this formula is for the C language. Okay, this is for C language. Okay, so now there is a generalization of this formula, that base address plus what we are doing here is I minus the row. Now generalization, I need this to represent in this case is A low 1, and I'll write here high 1. Okay, and I write here low 2, and then I'll write here high 2. Generalization means it is applicable to everywhere. Everywhere it will be applicable. Now, suppose I have written it as 110, and here I have written as 115. You can re-verify this result. So number of rows will be equal to number of rows will be represented by high 1 minus low 1 plus 1. Okay, 1 to 10. So I'll write here 10 minus 1 plus 1, that is equal to 10. Now suppose this is the low is the 4 and high is 8. Okay, for example, in that case also I write same thing, that 8 minus 4 plus 1, and that is equal to 5. So there will be for row number 4, 5, 6, 7, 8. So there will be total 5 rows. So number of rows will be represented by this high 1 minus low 1 plus 1, and similarly number of columns will be also represented by high 2 minus low 2 plus 1. So this is the generalization of any bound, any value of low and high I can write here. So base address I minus what? I minus lower. This is the row 1, this is the column 1. So this is, I'll write here low 1 multiplied by what? In original declaration, what is the value? How many number of element in the column? Just recall here, go back here and just see that number of element in each row, and number of element in each row will be equal to what? How many elements are there in each row? Okay, like here in this row, how many elements are there? So that is equal to your basically number of columns actually. How many columns are there? So there are 3 elements in the row, and as well as there are 3 columns are there. So number of element in each row is also equivalent to the number of element in the number of columns, total number of columns. So here we will write as high 2 minus low 2 plus 1. This is the number of columns. This is the number of, we are not talking about these are the many rows are there, 1 to 10 rows are there. Okay, we are talking about how many elements in a single row, and that is equal to number of columns, number of element in each row. This is what? Number of rows. What we want? Number of element in each row. Both are different quantity. So this plus j minus what? What should I write here? Low 2. And then finally I can put into a size. Okay, so that is how a 2-dimension array, a generalized formula is represented. So flatten the array is something to represent a 2-dimension or more dimension array into a single dimension. And let's take our example here, that if I say if I say A10 Okay, if I say that element is 8, 10, 10, okay, and size is equal to 4 byte, okay, and I want to assign 0 to this. Suppose the simple statement is that a I j is equal to 0. Suppose loops I'm not writing, I just want to assign this value. Suppose some I, some j, I want to assign it to 0. So the 3 address translation will be what? What will be the exactly 3 address translation? So I have to go to this formula. Okay, and formula says what? That one more point here, that lower bound is 1. Okay, so 1 to 10, 1 to 10 you can assume. So I have to write the formula as base address plus what? I minus 1, some random value of I minus 1 into number of columns. How many values are there in one row? That is number of column plus j into size. Okay, so now I can just rewrite this thing as a 10i minus 10 plus j and into the value of size is equal to what? 4. So now I can rewrite as 40i minus 40 and plus 4 times j, and plus I can add here a base address. So I hope I am clear over here. So now I'll translate this one into a flatten the array that I'll access somehow, that I'll access it by using one dimension. So what should I write here? I can rewrite this one also, and I can rewrite this one also. Let me rewrite this one, and this you can do by yourself. So I'll write here T1 is equal to I minus 1. Then I write T2 is equal to T1 multiplied by 10. Then I'll write T3 is equal to T2 plus j. Then I'll write T4 is equal to T3 multiplied by 4. Now this T4 has now the dimension, the correct value to represent the entire array in one dimension. So now I can say that A of T4, that means A of T4 will open and in what way? A of T4 will be A plus, okay, T4 into 4. Okay, that way it will open. So now I can finally say A of T4 is equal to 0.0. Okay, so I have just now this computation is still, there are many other computation here. The only thing is that A is the base address. A will represent here the base address, and plus I'll add the value of T4, and that is equal to 0.0. Okay, so this is the only computation that we are leaving. Otherwise we have done the entire computation. Okay. So this simple statement A of ij is equal to 0 is represented in 3 address form in this particular way, and this entire part, this part is this calculation part. This entire calculation part we are putting it in a 3 TAC, 3 address code. Okay, so I hope I am clear over here, that you understand that how can I represent a 2D array in 3 address code in form of a 1D array. Okay, so that's all for this discussion. And similarly, if there is a statement A of I, J and K, and you give me what a value of size of each element, size, and you give me lower bound, okay, lower bound, and if you give me all this information, I can still flatten this array, 3D array also. I can go with 3D array, which I can convert into a 1D representative array form. I can access this element over here. Okay, so that's all for this session. Thank you.